Hello, everyone. My name is Shamo Majuda, and today I'm going to talk about regression and hypothesis testing and why they matter in real life. First of all, why do we need these tools? We need these tools for making everyday decisions, such as uh, developing inferences, predicting house prices, and these are done through data. They guide us. They lets us do real life costs, and they help us going from just guessing to actually knowing what actually matters. So where do we use this type of tools? Well, mainly regression is used in different uh, spectrum of areas, but the most use case that it has on is on house prices, stocks, bonds, etc. It also lets us help define how a campaign worked or not. And also, it helps us making magnificent changes in our business metrics if you are interested in the business applications of regression. So these are some of the applications. Now let's look at what regression is and how it works. Let's move on. So what is regression? Well, regression is mainly a tool that helps us identify relationships between variables. Uh, there are there are some of the things that I would like to mention here. There's a model in regression depending on what type of regression you are using, such as linear regression, multiple linear regression, etc. So the equation would be based on the type of model you are using. For example, if you are predicting the house price, the model equation could be something like price equal to $100,000 plus 400 times area plus 10,000 times bedrooms. This is a simple model, but it could be much more bigger and more difficult. So yeah, that's a regression model. Now, according to Investopedia, regression is a statistical model used in finance and investing and other disciplines in order to determine the strength and character of the relationship between one variable, which is dependent, and another variable, which is independent. In this case, the dependent variable is denoted as y, and the independent variable is denoted as x mostly. So here's an example of regression model, which has an equation like y equal to a plus bx plus u. So in this case, y is the dependent variable and x is the independent variable. Now, how regression works? Well, regression is actually a best fit line through the data. So if we look back in this chart, we can see that this line is actually the linear regression line, and these are our data points. And this linear line is actually denoting the trend of the data, which way it is going. In this case, it's going upwards. So yeah, that's actually how regression works. And there are some measures of strengths and relationship directions. Like in this case, it was a positive upward relation, but it could be negative as well. There are some key outputs such as coefficients, R squared and significance. We're gonna talk about this when we work with real-time data. So let's move on. Next up, we are gonna apply what we have learned in this lesson using the regression and hypothesis testing tools to actually in a real housing data set and predict whether the price is dependent on certain variables using regression and um, how this action analysis is correct and the strength of this relationship through hypothesis testing. That's all. Now let's look at that. Let's dive into the data. Now we'll see how these tools actually work on real housing data. We'll use Excel. We won't be needing any kind of advanced softwares for this exercise. So let's look at Excel file here. So I've got this data set from Kaggle. It is housing data where there is the housing prices and different other variables such as area, bedrooms, bathrooms, stories, parking. Now, first of all, we're gonna do some modeling and build a linear regression chart and equation. Let's first do that. We're gonna select our data, in this case, area, and we are also going to select the housing prices to make our chart. So we've got the recommended charts. I've got this beautiful scatter plot, and we can actually build a trend line, linear line, and if you want to see the actual equation, we can do that as well. With the more option, just select the equation. And as you can see, we have got this beautiful equation. And this is the actual equation, regression of our regression model, which is going to predict our housing price based on the area. In this, let's do the actual regression analysis. So first of all, we're gonna show the one-on-one analysis. So let's select area again and price. Let's go to data and data analysis. And we are gonna select the regression. Okay, so in the input Y range, we're gonna select the labels to select the headers, and we're gonna predict the dependent variables in this case, which is price, and independent variable. In this case, this is area. Now, let's create a new worksheet. So we're going to create a new worksheet and let's do the analysis. Got this beautiful summary output. Let's break this down step by step, what we have got here. So in this whole output, we have got regression statistics. Here we're mainly going to look at the R square. Let's highlight this one. Because we use this R square to see how much our price of the housing data, it can be explained by the variable area. So in this case, we're selecting R squared because we have got only one variable. We could have used adjusted R squared if we had more than one variables. The standard error is very big in this case because um, there could be much more. It could be less if we had more variables to predict our data points. So this standard error would be much more lower, which we are going to look at next in our multiple linear regression. Let's look at significant F. It is basically predicting the strength of our analysis. In this case, it's uh, much less than significant F, much less than P 0.05 p-value, which is actually saying that this is actually true. And if we see this housing price can actually be explained by the variable area. Now, that's for one variable. Now, let's look at multiple linear regression with 4 to 5 variables together. Let's do that right now. So first, let's select our data and go to Data tab, Data Analysis, Regression, and we have to select our data in this case. We're in the input Y range, we're going to select the price. And in the input X range, we're going to select area, bedrooms, bathrooms, parking, and stories as well. We're to select labels as well. Let's do this. And we're going to get this here. And as you can see that the adjusted R squared would be the one we're going to select because we have got more than one variable. So we can see that the strength of our analysis is much more higher, as we can see that this was when we used only one variable, it was only 0.28. But in this case, when you're using more than one variable, it's more than 50%. Still, the standard error is pretty high, but it's not as high as the previous one. It's much, much lower, which we definitely appreciate because when the standard error is lower, our analysis is more correct. And the significant F, which is the number here, which is definitely less than p-value 0.05. And so we can definitely say we are going to reject our null hypothesis. Let's look at our p-values over here. We have got this number, this number. We can see that area is less than 0.05, but here as well, here as well. So we can definitely say that our analysis is correct, and we can actually say that these variables are actually good predictors of our housing prices. Our analysis results tells us that we have to do the housing price analysis and predict the house prices, not just based on area, rather than we should focus on these other factors as well, such as bedrooms, bathrooms, and how many stories does the house have, and if it has one parking, two parking, etc. We have to take all of these things into consideration before making any decisions. And that's the finding of this analysis. Hope you enjoyed this video. Thank you for watching. See you later.